Okay, we are going to talk about piecewise functions. We've got 3 learning goals up there, the first of which is to be able to evaluate piecewise functions for given values. Now, before we can do that, we probably should look at the definition for piecewise function. So a piecewise function is a function represented by a combination of equations. This one has 2. There can be more, so it's not always just 2 equations. It could be 3, 4, 5, an infinite number of equations that you could possibly have defining your piecewise function. But what that means is that this part of the function defines it if x is less than 1 for all the values of x that are less than 1. So not only 0, -1, -2, so on and so forth, but decimals and fractions in between there as well. The second piece here, y equals -3x if x is greater than or equal to 1, means that for every x value that is 1 or bigger, we would define the function using this equation. So we're separating it into pieces, which is why we call it piecewise. So to evaluate f of x for the given value of x, this is just plugging in, but you have to make sure you're plugging it into the right place. So when I look at example 1a, it asks me to find f of 0, which means that I am finding what the value of the function is when x is 0. So when x is 0, I need to look and see which of those equations am I going to plug it in. So if I look over here, I need to see where my 0 fits. Is 0 greater than 3? No, it's not. So that means it fits up here. 0 is less than or equal to 3. So I am going to use this top part of the equation to plug my 0 in. So I have here then 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 is 2. So that would be our final answer there. Thought I selected red for my color. Let's see if it'll work this time. So f of 3, again, I have to look over here first. Is 3 greater than itself? No. Is 3 less than or equal to itself? Yes, it is equal to itself. So again, we're looking at the top equation to plug my 3 into. There's the red. 3 times 3 plus 2. So 3 times 3 is 9. 9 plus 2 gives me 11 for my answer. Last one, f of 6. So I'm looking where that fills in. 6 is greater than 3, so that means I'm using my bottom equation to plug 6 into. So 6 minus 1, which gives me 5. And that is it. So that is how we deal with our first learning goal, evaluating piecewise functions when they give us the values. Our second learning goal is to be able to graph piecewise functions. So that's what we have in example 2 here. So in order to graph a piecewise function, you have to be able to graph a line. I really hope you haven't forgotten how to graph a line because it's the second most important thing from Algebra 1 other than remembering how to solve an equation. When we graph a line, we use y equals mx plus b, where m is your slope and b is your y-intercept. So, if you are using pen right now, I highly suggest that you trade it out for a pencil because the easiest way to do this is to graph the entire line and then erase the parts that you don't need. So, I'm going to be using different colors because I don't have an eraser tool here on the computer. So I suggest you use pencil because then otherwise you don't want to write things that you don't really want there in your final answer. So I am going to use green for my work and I'm going to go over my final answer in a different color when I get there. So we're going to look at the pieces separately. So right now I'm just looking at this part. So that really says, basically, because f of x is the same thing as y equals x minus 2 if x is less than or equal to negative 1. We're not going to worry about the if part right now. We're just going to worry about graphing this line. Y equals x minus 2. Again, I hope that you remember this. If you don't, look up it here. M is the number in front of the x. Here, there is no number in front of the x, so it is implied to be a 1. So my slope of that line is 1. Y-intercept is the plus b. Here it's a minus, which means that b is negative. So my y-intercept there is negative 2. So if my b is 1, or my b is negative 2, my m is 1, that means you always start when you graph a line with the y-intercept with the b. So I start where y is negative 2, which is down here. Again, if you're doing this in pen, don't do anything yet. There's my y-intercept. Now I use my slope, which is 1. That means rise 1, run 1. Rise 1, run 1. Continue rising 1 and running 1 until you're off the page. Do the same thing in the other direction, because a slope of 1 could also be down 1 and left 1 until we get off of the page. So you can see where my line would be. I'm not going to draw my line in yet because I don't want the whole line. All I want on this piecewise function is the part of the line where x is less than or equal to 1. I always get people get confused that they want the y part. It says when x is less than or equal to 1. So if I want x to be less than or equal to 1, I need to go on the x-axis, which is this one. On the x-axis, x is negative 1 right here. So that means find that point on the line. That's right here. This is going to be what we're going to call your breaking point. You're either going to have the part of the line that is to the left of that, or the part that's to the right, or if you want to say below and above. The breaking point is just like graphing the inequalities. Because this is a less than, it's going to get an open circle on my breaking point. So I got my open circle here. Which part of that line that I want is determined by the symbol. Less than, x values that are less than that breaking point are over here. So that means, and I can't use a straight edge either, so sorry. This is not the neatest. But that is the part of the line that I want. So the rest that's in green, I don't need that. So if you're using pencil, you can go ahead and erase it. It's not part of your answer. Erase it away. Now let's look at the second part. So I'm going back to my green. Now I'm graphing y equals 3x minus 1. So my m, my slope is 3. My y-intercept is negative 1. So we always start with the y-intercept, so go to where y is negative 1. There's my y-intercept, down 1. Now, a slope of 3 means rise 3 and run 1. Rise 3, run 1. Or, from here, you could also go down 3 and to the left 1. So, in here is where my line would be. Again, I don't want the whole line, so I'm not going to connect that. I'm going to see what part I want. My breaking point is at negative 1 still, so that means on that line I want to find where x was negative 1, which is this point right here. Because this is a greater than or equal to, it is a closed circle because I'm including that point. So closed circle, and because it's greater than, that means I want the x values bigger than negative 1. X is bigger than negative 1 over here. So that means I want this part of the graph. And again, you should be using a straight edge. I cannot use a straight edge on the computer, so my lines look like squiggles, but hopefully yours do not. All right, this is tricky. There's a lot of little steps, so let's try another one of these to work on that second learning goal. Use a different color again. How about maybe kind of a light blue? So I'm starting off, my top equation is y equals 2/3 x plus 2/3. So that means my m is 2/3, my b is also 2/3. So we always start with the b, think alphabetical order, start with the b. Up 2/3 means it intercepts the y-axis at 2/3. So that's not quite 1. So go 2/3 of the way up to 1. That's your y-intercept. From that point with a slope of 2/3, that means go up 2, right 3. So up 1, up 2, and then right 1, 2, 3. Again, it shouldn't be on an exact dot because we had the 2/3. Then you could also, instead of going up 2, right 3, you could also go down 2 and left 3. Now, if that's all we were doing is graphing that line, I would connect the dots here. I'm not connecting the dots because this is piecewise. I only want the part of the function where x is greater than 2. So 2 is my breaking point. So I need to find where x is 2 on this number line. So this is my x-axis, x equals 1, x equals 2. So I go up to where that line would be, and I'm going to put an open circle there. I only want greater than, so the values bigger than 2 are this way. So that means this part of the line. Now the second part. Y equals negative x plus 1. That means m is negative 1, because that's the number in front of your x. B is positive 1. So always start with the b. Positive 1 means right here. So just a tiny bit above the other y-intercept. A slope of negative 1 means down 1, right 1, down 1, right 1. Or you could also go up 1, left 1, up 1, left 1, so on and so forth. Now, I don't want to graph the whole line. Go to my breaking point, which is where x is 2. So here's where x is 2 on that green line. This one is going to be a closed circle. And it says I want the part where x is less than that breaking point. So that means this part is what I'm connecting. We're going to practice an awful lot of these. If you know that you have struggled with graphing equations, you might want to get online and find an online game or some extra practice problems that you can look at, because you have to be able to graph a line, that Algebra 1 skill, in order to graph piecewise functions. So hopefully you feel more comfortable with that second learning goal. I can graph piecewise functions. The last one is just working backward from that. I can write equations of piecewise functions based upon their graphs. So that's what we have in example 3. So, oh, and I forgot in example 2b to make this red, but not that it matters. I'm sure you all caught that on there we go. Write equations for the piecewise function whose graph is shown. And on your papers, you have the dots here. I don't have them on the computer, so I'm going to put them on now because I couldn't get them on my Word document, at least not the circle small enough. So you've got something that looks like that. Now, all this is working backward from what we did in example 2. Instead of taking the equations and putting them on the graph, we're taking the graph and putting it into an equation. You're going to work one piece at a time. Again, that's why it's called piecewise. I'm going to work on this piece first. First thing that you should do is extend the line using the slope that you see. So if I'm looking at the points that are on here, here's a point, here's a point, here's a point, you can count the rise and run in order to find the slope there. So if I look at rise over run is my m. In this case, if I start at this point and go to the next one, I went up 1, so my rise was 1, and then I went right 1, so my run was 1, which means my slope is 1. So my slope is 1. I need to continue that slope to keep graphing the rest of this line that would be there if this weren't piecewise. The reason why you need to do that is because we need the y-intercept. We need to see where it crosses the y-axis. Here's the y-axis. It's crossing where y is 2. So that means my b value is 2. So that means that this equation, and you can either use f of x or y, it doesn't matter. For the top piece, if we're looking at y equals mx plus b, I know my m is 1, my b is 2, so that'd be y equals 1x, which we can just write as x, plus 2. Now, I need my restriction because I don't have that whole graph. So look at where the dot is. That's the breaking point. That breaking point is where x is -1. You're not looking at the y value, you're looking at the x value. The x value there on that breaking point is -1. So if x, and then we know it's going to be -1, in order to get the symbol, see which part you have. Is this part x values less than or greater than? And what's in black is the less than. You know it's not an equal to because it is an open circle. So x plus 2 if x is less than -1. So now we need to look at the other piece. Again, I need to find the slope and the y-intercept. So if I'm looking to see what points I see this point right here, which is my y-intercept. That tells me b is 0. My y-intercept is 0. Other points that I see on here that are at exact places, there's one here and one here. So if I count rise and run, my rise is -1. I went down. From my y-intercept, I went down 1 unit. So -1 over the run. After I went down 1, I went 1, 2 to the right, which is positive. So my m, my slope, is -1/2. So if I'm doing y equals mx plus b, that means f of x equals m x plus b. Well, we don't write plus 0, we just leave it off, so we don't need anything else there. Now for restrictions. If you look at that, again, the x value at that point right here where my closed circle is when x is -1. And the part of the line that I have is when x is greater than it, or because it's a closed circle, or equals. So then this becomes our equations for that function. And that's all for this lesson.